Hello everyone. So today we'll be discussing on the seventh data structure lab program. Seventh program is on singly linked list. So let us understand what are the operations to be performed before starting the implementation. So seventh program is on some of performing some of the operations on singly linked list. So according to the questions given in your syllabus, what you need to do here is to design, develop and a menu driven program. So it is similar to the previous lab program where you have considered menu driven programs using switch cases. So implement that in C for the following operations on the singly linked list. Okay, so and this operation is we are performing on the student data. Okay, the student data contains different fields. According to the question, we have to consider all these fields. So some of the fields given by the particular syllabus question is USN, name, program, and semester phone number. Program indicates it is the branch which is considered. Okay, so you have to implement a C program for using the singly linked list concept for doing some of the operations for the student database with these fields indicated. Let us see what are all the operations to be performed. First operation is to create a singly linked list for n number of students using the front insertion. Okay, explicitly they have mentioned in the question that we have to create a singly linked list for n number of students using front insertion concept. That is first operation to be considered. Second is to display the status of singly linked list and also to count the number of nodes in the particular list. Okay, so second operation will specify all the details related to singly linked list, that it displays the data of individual node and also it counts the total number of nodes present in the particular linked list. That is the second operation. And the third operation is to perform insertion and deletion at end. Okay, end of the singly linked list. So as there will be two types of insertion like front insertion and the end insertion, third operation is on performing insertion and deletion at the end of singly linked list. Fourth one is to perform insertion and deletion at front of a singly linked list. Okay, so using this front insertion and deletion, so singly linked list can also be used for demonstration of the particular operation of stack. Okay, so hence fourth operation we will be performing both insertion and deletion at the front along with demonstration of the stack. Okay, so fifth is normally the exit case for your switch case, switch choice. Okay, so this seventh program, we have to create a menu-driven program using switch case with for the student record with following operations. We have to consider all these five operations. Okay, so let us understand before going for implementation. Let us understand how do we implement this in C. Okay, so let us understand the basic concepts of linked list. So when you consider a linked list, as already you know, it is a collection of nodes where every node will be having the data part and the link part. Okay, so we know that it has a data part and it has a link part. Okay, this is the general node structure for any singly linked list specified. So using this linked list concept, now we have to consider the insertion and deletion operations for student record. Okay, according to the question, when you look back to the question, according to the question, they have mentioned that so we have to consider a student data with the different fields specified. Okay, so there are five fields: USN, name, program, semester, and phone number. When you consider this as a node structure, according to the linked list, we have to use singly linked list concept here. When I say the singly linked list, you know that it has data part and link part. But according to the program, we have a student record with so many data indicated. Okay, so how will the node structure will be according to our example? Let us understand that particular concept. Okay, so here the data part of the particular student record can have the five fields indicated. Okay, so normally you know that it has a data part. Okay, so using that data part, now I can consider data part for the student record. So let us understand the data part. Okay, first is USN, second is I'll check. Okay, second is name. Third is program. Program I can consider that as branch. Then semester and phone number. Okay, semester and phone number. And finally, the link part. Okay. So when you consider the student record for this particular example or the exercise, so if you are considering the student record, for this student record, the data part indicates for a node, data part will be having these five things. Okay. So that is USN, name, branch, semester and phone number, and a link to the next node. Okay. Because it is a collection of nodes, it is a link to the next node. Okay, every node in the particular example, every node should have these data part indicated. Okay, already I have explained this in the theory concept as well. So data part can be a single data part, or it can also have two or three data elements indicated. So here the student record will contain these particular data part, that is USN, name, branch, semester and phone number. So all this should be present for each and every nodes. Okay, so now this is the node structure considered. According to the node structure considered, let us look at the first function here. So first function is to create a singly linked list of n students data. Okay, you have to create a singly linked list for n number of students using the front insertion concept. Okay, so it indicates we can take any number of students depending on the value of n. You can give the value of n as 10, 20. It indicates 10 number of students or 20 students. If the value of n is equal to 10, it indicates you will be having 10 number of nodes because it is a linked list. Okay, every node, if it is having 10 nodes, every node should have these particular data part. Okay, so that is USN, name, branch, semester and phone number. So with this concept, so we will check with other operations also. Okay, so second is to display the status of singly linked list and count the number of nodes. Okay, suppose if you have data part indicate, suppose if you have n value is equal to 10, in that case you have to indicate, it indicates you have 10 number of students. Okay, so it indicates 10 students. So for all the students, you will be having all the six data part indicated. Okay. So first operation is to create a singly linked list. So creation of the singly linked list, you have to specify total number of students, and also second is to display the status, means you have to display the contents of each of the node and also count the number of nodes present. Okay, third operation is to perform the insertion and deletion using the end. Okay, so insertion and deletion can be done according to different way. You have different ways of insertion: insertion from the front, insertion from the end, or insertion in the given position. We have three types. Okay, so already we have studied that in theory as well. So when you consider this particular question, they have mentioned that insertion should be done from the front and insertion to be done from the end. Okay, there are two things indicated, and also they have mentioned that fourth operation, they have mentioned that it should be done for demonstrating the stack also. Okay, so when you have insertion and deletion at the front, the demonstration of stack has to be done according to the question, and finally the exit case. Okay, so before that, let us understand this particular concept. What happens if I go with inserting at the front? Okay, so according to node structure, you know that it will be having 10, suppose 10 students are present. So for every student, you will be having data part indicated as USN, name, phone number, branch, etc. So if you have 10 number of students, you will be having 10 number of nodes. Okay, so each node will be linked to the next node because it has a link path. As of now, I will only consider three nodes only for understanding purpose, and also we consider that last node will be having null character in its link path. Okay, and also there will be a pointer called first, which will be pointing to the first node. Okay, so this concept you already understood in the theory as well. So first is a pointer, or I can also consider that as a node or header node. Okay, so this first will be always pointing to the starting node in your linked list. Okay, so I'll just indicate the data part as USN of the student. Suppose USN starts with 1, that is the first student record. The second is USN is 2 for the second student. USN is 3 for the third student. Okay, so we have three nodes indicated. So don't get confused that it will be having only this data. 1, 2, 3 will not be there. So it should have the complete data part like USN, name, branch, semester and phone number. Okay, only for understanding I have taken data to be USN equal to 1, 2 and 3. So according to this example, what is our job is to create a student record. Okay, so first up we know that we have to create a number of students, and also it is done using front insertion. Okay, so how do we do front insertion? So front insertion will be done from this end. Okay, from the left end we will be doing the front insertion. If it is the end insertion, we will be doing from the right hand side. Suppose you have to add a node from the left end or from the front end. Okay, so I'll just consider this as front end. Okay, so because you know already in queue concept, front will be at the left side where you'll be doing deletion in the queue concept. Rear will be at the right side as soon as you increment. Okay, same concept is also applied here. Front insertion will be from the left, whereas rear insertion or end insertion will be from the right side. Suppose I want to insert from the front. Okay, let us understand how this can be done. I have a new node. This is the new node I am creating. Okay, with USN 4. Consider the USN is 4. I just want to insert a node from the front side. Okay, for doing the insertion from the front side, this is the new node created. Using this new node, I have to append this new node to the right side of the first. Okay, initially first is pointing to 1. Now after front insertion, 4 will be my first node. Okay, how can we do that? It is, I just consider here. Okay, this 4 has to be inserted before 1 according to our concept, since it is a front insertion. So how do we do? I am going to link this particular 4 to the front end. Okay, so link part of 4 will be now pointing to 1. It indicates it is a front insertion. After doing this, next step is I have to change this first. Okay, first should be now pointing to your 4 because that is my new node created. So I just indicate the value of front. Okay, so this first will be now pointing to here. Okay, it will now point to 4 because that is my first node after front insertion. So front will not be present here. Okay, there is no front indicated here. Front will be now, first will be pointed to your 4. Sorry, it is not front, it is first. Okay, so whenever you want to insert a new node, the job is first you have to create that particular node with the data part indicated. So data part should contain all the details of student like USN, name, branch, semester and phone number. Okay, consider I have created a new node, it should be added to the front. How do you add it to the front? I have to change the link part of 4. It should now point to the node which is already present in the linked list, that is first node, because 4 should be inserted before 1. So hence a link is created, and after a link is created, 4 becomes my first node. Hence this first pointer will be now pointing to 4, that is the new node. This is an example of front insertion. Similarly, in the question, they have also mentioned that we have to do the insertion from the end. Okay, so let us consider that example also. When you are doing the end insertion, first job is to create a node. I have to create the node. So node can have the data part. I just consider the USN to be equal to 5. Okay, so this is the new node created where link part is initially null. Link will be initially null. Suppose if I want to add from the front, this 5 should be added after 3. Okay, so normally when you consider the last node will be having the link part equal to null. Suppose if I want to add 3 after, suppose you want to add 5 after 3, what you need to do? You need to just change this link part of 3. Initially it was equal to null, but now link of 3 should now point to the node, that is new node which you have created, which is equal to 5. Okay, earlier 3 was my last node, but after you create a new node 5 which is to be inserted after 3, what happens? 5 becomes my last node because you are doing the end insertion. When 5 becomes the last node, what happens to the link part of 5? Because that is the last node, we will be indicating null as a we will be indicating null in the link part of that particular node. Okay, so this is the concept of inserting from the front, okay, and also deleting, sorry, and also inserting from the end. So we have done insertion from the front and also we have done insertion from the end. Similarly, we should also check how do you delete from the front and how do we delete from the end. Okay, so according to our example now, 4 is in the first location followed by 1, 2, 3 and 5 is in the last location. Similarly, we will check how do we delete. Okay, so while doing the deletion operation from the front, my front node or first node to be deleted. Suppose I want to delete this node. Okay, 4 is my first node. Suppose I want to delete this particular node. How do we delete it? First, I need to identify this link. Okay, so before identifying this link and also after deleting this particular node, what happens? My first should be changed. First was initially pointing to 4. After 4 gets deleted, after you delete this particular node, first should point to the next node available. That is equal to 1 in our case. Okay, so what I can do here is this first will be now pointing. Yeah, you will not be having this first here. Okay, so there will not be any link indicated. So I can remove this particular link and first is now pointing to 1. Immediately what you can do, you can start deleting this particular node. Okay, how do we delete it? You have a memory dynamic memory allocation functions and also deallocation function. Okay, while creating we use dynamic memory allocation function malloc. While deleting you can use free function. Okay, so what happens? Your first gets changed. First will now point to 1 and the link of that can be removed, and what happens, you can call free function for deallocating the memory which was allocated for the node 4. Okay, 4 gets deleted, so then first will be now pointing to 1. Similarly, if you want to delete from the end, while doing the deletion from the end, what happens when you want to delete 5? Because 5 is my last node. Okay, when you delete 5, what happens to the link part of 3? 3 should be changed because 3 becomes your last node. Okay, this becomes my last node. Always the last node link should be indicated with null. Okay, hence what you can do, the link part of this 3 should be changed to 0 or should be changed to null. Okay, here you can indicate it as 0, indicating that you are deleting 5. Once the last part or the link part of 3 is changed, now I can delete this particular node. Okay, 5 can be deleted using free. So 5 deallocation happens, the memory allocated for this particular node gets deleted. So this is how I can use memory allocation functions malloc and free So free, you can directly use it for deletion purpose, whereas malloc you can use it for the creation of new node. Okay, so this is the concept. So using this, I can also demonstrate your stack operation. Okay, so according to the example, okay, you can see in the question. Okay, so we have seen how do we insert and delete from the end, and also we have seen insertion and deletion from the end, the deletion from the front. But also in the question they have mentioned that it should be used for demonstrating your operation of the stack. Okay, so when you consider insertion from the front and deletion from the front, it is almost similar to the operation of your stack. Okay, so let us see how that works. So when you consider front insertion and deletion, okay, this side I'll consider as front. Okay, front is this case. So when you consider front and for both insertion and deletion, so this is almost similar to the operation of stack. Okay, so whenever you insert, already if there are three nodes present in your linked list, consider this is your stack. When you have three nodes indicated, so 1, 2, and 3. Okay, because my first node is 3, which was earlier created. Then again you had 2, then 1. Okay, so when you have the situation like this in your stack, to do the front insertion, what you will be doing, you will be doing the insertion from the left side. Okay, insertion will be done from the left side. Suppose 4 to be inserted here. Okay, when you want to insert 4, you have to change the link part of this to point to 1. Okay, 4 will be on inserted on the top. This is similar to the stack operation. So which element will be deleted here? Topmost element will be deleted always in the stack. So this is my topmost element. So again you apply deletion from the front. Okay, so deletion from the front is you have to delete this particular node, that is 4. 4 gets deleted, and also when you look at this particular stack operation, on top of stack you have 4. Okay, so 4 can be deleted, or this particular element. Okay, so this first node can be deleted. When you delete the first node, it is also similar operation of stack topmost element is 4, that is also deleted. Okay, so this is almost, the concept is almost similar to your push and pop operation. So three is at the bottom position, 2 is at next level, and 1 was at the top level. But if you want to include a node to the left of 1, what happens? 4 will be present at the first location. So 4 will be on top of stack. So front insertion, 4 gets placed on top of the stack, and also front deletion, 4 gets placed on top of the stack. Concept to be considered. So front insertion and deletion is almost similar to the operation of your stack, that is last in first out operation. Okay, so last inserted element, that is last inserted from the front, will be on top, that will be deleted first. That is the last in first out concept. Okay, so using this concept and also with your understanding, so maybe we can start implementing now. So for all these operations. Okay, so and coming to second operation, it is only displaying the contents of each of the node and also count the number of nodes. Okay, you can start from the first node, and you can continue until you reach the last node. So how last node can be identified? So you already know last node will be having null in its link part. Okay, so usually normally when you want to display, we will start from the first node. Okay, then we move to the next node. How do we move for the next node? By using the link part. Using the link part, I can directly move for the next node. Again, you move for the next node by its link part and identify what is its link. Since the link part of this is equal to 0, I can stop at that particular point. Okay, this is how I can move from one node to another node by using its link part. So this concept is used in display purpose. Okay, we will start from the first node and we will reach till the last node. To identify the last node, we will be checking for the link part of that particular thing. Okay, so using this concept, now we can start implementing that in C. So if you are using Turbo C, you can make use of it, or maybe if you are using code blocks, you can also work on that. Okay, so let us understand the implementation in C. So as usual, include the normal header file. So after this, now you have to define the structure or declare the structure. Okay, so normally how do we declare a structure? By identifying the node structure. According to our example, when you consider the student record, what is the node structure? In node structure you have a data part and the link part. Okay, what is the data part? According to our example, it is USN, name, branch, semester and phone number. We have 5 things to be included in the data part. Okay, along with that you have a link part indicated. So let us define the structure with the particular node structure considered. This is struct list. We are defining a singly linked list structure. So since you have 5 data part indicated, all the 5 to be defined. USN. Okay, initially I'll consider USN to be a character type. Okay, and also another field is you have USN. Okay, sorry, another field is you have name. Name can also be a character array with some specified with 10. You can also increase the size, and also program. For program, either you can consider that as branch like CSE, EC, or also you can consider that as program. Then int semester for the semester, then character, phone number with some 15 characters. I'm just restricting it to 15 because it may also include your country code like +91 something. Otherwise, you can also consider that as 10. So this is the data part indicated in the node structure. Okay, so every node in this particular example program, you should have this particular data part indicated for the student record. So once data part is indicated, next is to identify the link or specify the link. Okay, so usually as we already discussed in the classes, so we consider that to be a pointer, okay, which is of same structure. It is a pointer variable of same structure. It is also specified as a self-referential structure. So why we are defining the self-referential structure? Because again it refers to the same node. Because when you consider a linked list, the address of that particular link, when you have a link to the next node, so this particular next, it is a pointer which holds the address of next node. Okay, when it holds the address of a next node will also have the data part and the link part. Hence we consider this particular node, particular pointer, that is next, or it is also considered as a link. Okay, it is considered as a pointer, and also it is specified as a self-referential structure. Okay, so this is the structure declaration with the data part indicated and also the link part indicated. After this, now you have to define the structure variable which helps in the memory allocation for all the data members indicated. So this is type def struct list node. Node is the variable, structure variable indicated, which can have or which can hold all this data part and the link part. So this is the structure declaration. So after this, next step is to start implementation. So normally we have to consider as a specific example given in the previous programs also, and in this question also they have mentioned that it should be menu driven program. We will be considering a menu driven program. So I'll start with the main function. Let us consider the main function first. Then you can start declaring the variables I n for the total number of students. Okay, then choice because it is a menu driven program, and I need I because for every student I have to read all the data. Okay, then we will start with defining first variable or first pointer. So as already explained, first will be always pointing to the first node in your data in your linked list. Okay, so now we will define a pointer called first, which is of type node. What is node here? Node is a structure variable. That is, we have already defined node as a structure variable. So using my structure variable, we are defining a pointer called first. This first can also hold the address which contains the details of a node like data part and the link part. Okay. Initially, since we don't have any nodes indicated, so starting what we can initialize is we can initialize the value of this to be equal to null because it is the initial condition. There is no node created yet. We have not created any node and we have not inserted any value. Hence, first is initialized to null. Okay. After insertion, so first can be pointing to your first node in the list. Then you can specify the option for clearing the screen. Then you give the choice like simply you can specify the display criteria here. Okay, so it is a program on singly linked list. You can just create your own menu whichever is comfortable. This is it will display singly linked list. Then we'll start with your choices. So we have to specify the choice here. According to the question given, we should perform 4 operations and last operation is the exit case. So we shall give all those cases here. First one is to create the list according to the operation or question given. Then second is to insert from the front. Third is to insert from the end. Fourth one is to delete from the end. Or what I can do, I can start with front and then go with end. Then fifth is to delete from the end. So you can do one thing, you can type this complete thing in a single printer statement, or you can also divide it into different printer statements. Both are okay. Next is to display, because we need to display the contents as well. 7, we will go with the demonstration of singly linked list as stack. Okay, then finally the last case is exit. So after this we have to specify the choice to be entered by the user. We'll be using scanner for getting the choice. Scanner. Then switch case. Okay, switch choice. So now we have to start with specifying each cases. So according to our menu which we have considered, we have considered create list as the first option, and also in the question they have mentioned that list creation should be done from the front. Okay, so and also it should be created for n number of students. So hence we have to consider the value of n because n number of students to be considered. So hence specify printer, enter the number of students. Then specify scanf for reading that particular value. Okay, so as we know that insertion and creation to be done from the front, while creating each of the student record, so we have to consider for loop here, because for each student we have to read all the values like USN, phone number and semester, etc., because that is the data part. Okay, so for each value of n, or I can consider for loop to be starting with 1, and for I less than or equal to n, I plus plus. Okay, so here what we have to do, I just use first is equal to insert front. We are calling a function to do the insertion from the front. So this is the function call, because in the question I have mentioned that for each of the students we have to create the record, or we have to create the singly linked list. Hence, for each of the students to do the repetition by using the front insertion, we are considering the for loop and also specified front insertion. Okay, so initially we are passing the value of null, that is the initial condition, because still it is not created. Okay, that is the end of case 1. Then we can directly come out of the case 1. Okay, so what I'll do, I'll just complete all the cases. After completing all the cases, then we will go with the function definition. Okay, so second is to go with insertion from the front. Okay, insert front, just call the function insert front, and input argument for this will be the address of front. Okay, so then finally you can go with the definition later. Then you can directly break particular case. Okay, this is the end of case. Then case 3 is to insert at the end. While doing the insertion at the end, I just call the function like insert end. So all these are the function calls. We have to write the function definition. That is the end of this case. Then case 4. So according to case 4, it is delete from the front. So we are just calling delete front the function. With the input argument first. Then you can exit from the case 4. Then case 5 is delete from the end. First is equal to delete end. Okay, with details of the address of first, that is related to case 5. Case 6 is display, as we have given in the menu. Just call the display function, then exit from the particular case. After case 6, next is case 7. Case 7 is to demonstrate the stack operation. Okay, I'll just call the function called stack operation. So for this we have to write the function definition. So in main function we are just calling all the function. So the definitions has to be written. So fourth case is seventh case is stack operation, and case 8 is the final one, that is exit case. You can directly come out of the particular program. Okay, so then that is the end of switch case and while one and the main function. Okay, so we have completed main function, switch case, while, and main. Okay, so there should be three braces to be closed at the end. Okay, so follow the proper indentation so that it will be easy to understand. So now for each of the cases, we have specified function calls. Every function calls, now we have to write the function definition. So what I'll do is I'll just write the function definition before main function. So why we are using before main? Because we can avoid the declaration. Function declaration can be avoided. I'll start with the initial function. Okay, so first is to insert from the front and also to create the total number of nodes based on the value of n. So for doing that, I'll just use the structure variable node star insert front. Okay, so why we are considering the structure variable here is after doing inserting from the front or after creating your number of nodes, it will be returning the address of the node. Okay, that should hold the address of that particular node. It returns a node, hence we have considered the particular return type as a node, and also we have considered this as a function pointer. Okay, it should hold the address. And input parameter we are passing is the first value, hence I'll just take an input argument as first. It is also a structure variable because it should also have a node structure with data part and link part. Okay, so in this particular insert front function, so here is to create, first operation is to create the list. So how to create the list? I have to temporarily create a node and assign the value for it. Then I can append to my list. Okay, for doing that, I'll just create a temporary variable. This temporary variable is for creating a new node. Okay, so we have just created a variable. So for this variable, it is considered as a structure variable which can hold all the data part and the link part. Using this, if I want to create or allocate the memory for this temporary variable, we will be using the malloc function. Okay, malloc, we can also say that as malloc. Temp is equal to, normally we have already seen the syntax, struct list. Okay, or you can also consider that as node malloc and specify the size of, I'll just specify it as a node because it is a structure variable. Okay, so now the malloc will allocate the memory for my temporary node. After that, if memory cannot be allocated, suppose if there is a failure condition in malloc function, the temp will have the return value equal to null. Okay, on successful condition, malloc will return the address to temp, but on failure condition, malloc will return null value to temp. In that case, I should have a condition that if temp is not equal to null, what I can say, if it is not equal to null, I can say that it is allocated the particular, it has allocated the memory. Okay, memory is allocated. Okay, so if memory is allocated, I can now assign the value for the data part. Okay, so now temp has been created and also memory is allocated for temp. Now the data part of temp will have all these variables like USN, name, program, semester and phone number. We should now get the values of each of the data member. Okay, so for getting that, you can directly go with printf and scanf statements for entering the data part. Enter USN, name, branch or program. If you want, you can write it as program also, semester and phone number. Okay, so all this data to be entered, then specify scanf. Okay, so scanf percentages for name, percentage S for the branch, percentage D for the semester, and again percentage S for the phone number. Okay, so now we have to get the value. So how do we get the value? By considering the temporary variable. Okay, because we are now assigning the value for temp. So how to assign the value for temp is by considering the uh, the operator called dereference operator. You can use the dereference operator and get the value. Okay, ampersand temp of arrow mark. This arrow mark is used for uh, accessing the data members. Okay, the accessing the data members means what are the data members? USN, name, phone number, and semester. Okay, for all this I need to get the values from the user according to the student record. To get that, since your temp is a structure variable and also it is a pointer, instead of using the dot operator for accessing the data from the structure, what I'll be doing, we'll be using the arrow operator, because always when it is a structure to pointer, we will be using this member function, or we'll be using this operator, or you can also call that as dereference or arrow operator for each of the cases. Okay, that is, first one is USN, second is temp of name, then third is temp of program, then temp of semester, then temp of phone number. So we have considered all the five data part. Okay, after considering the data part for temp, next is to identify the link part. Okay, as of initial condition, since it is the first node we are creating, I'll just assign the value of link part to be equal to null. Okay, so this will just create a temporary node and it assigns the data part and also specifies the link part for a particular node. Okay, so link part and data part is done. Afterwards, we will check whether you have a data already in your node. Okay, suppose if already there is a node available, first we'll be pointing to that particular node. Okay, suppose if the value of first, consider, suppose there are no nodes in the linked list. We are just creating the first node. When you are creating the first node, initially the condition of first will be equal to null because you don't have any node in the linked list. When you don't have any node in the linked list, whatever the temporary node you are creating, that itself will be the first node. Okay. In that case, what we can write? We can write it as return temp. Okay, so this temp will be returned for this particular function. This function will return temp that will be assigned to your first. Okay, because why it will be assigned to first? Because you can see here first is equal to insert front function is called. Whatever the function returns, that will be assigned to your first variable. Okay, first will contain that particular node. So now according to our example, if first is equal to null, what happens? We are going to consider that the list is empty. When the list is empty, the new node which you have created using temp, that itself becomes your first node. Okay, we will just return that particular node. Suppose instead of having null character in first, okay, so it may also have a node. Okay, you can also have a node something like this. Suppose you have a list which contains some items like 10, 20 and 30. In this case, the list is not empty. First will be pointing to 10. So when first is pointing to 10, your value of first is not equal to null. The condition becomes false. I cannot return this particular temp. Okay. So this condition works only when the list is empty. Okay. I can say that when list is empty, temp list is empty, temp becomes first node. Temp itself will be the first node considered. temp becomes the first node. Temp becomes the first node. Afterwards, you can indicate. Okay. So here, if the first node is equal to null, you can specify it is empty. You can directly return the temporary node available. Afterwards, suppose if you don't have a situation where list is empty, you consider now the value of list is having three nodes, that is 10, 20, and 30. In this case, how do you insert? Okay, what are the changes to be done in this particular insertion is you have to change the value of first because it is a front insertion. So how it should be added? It should be added before 10 because already three nodes are present. Now I am considering another temporary node. This should be added before 10 because that is my first node. So while doing that front insertion, how can we write the C implementation is first we change the value of temp of next, that is temp of link will be now pointing to first. Okay, suppose temp contains, I just indicated here, okay, temp is equal to 50. So this 50 should be added before 10. Okay, after insertion, it should be 50, 10, 20, and 30. Okay, so for doing that, 50 is my temporary node. The link of this 50, okay, the link of 50 should now point to first. What is first? First is equal to 10. Okay, so 50's link will now point to 10. That is, we have added 50 to with 50 before 10. Now 50 should be my first node. Okay, so to do that, what we have to do, we have to consider what happens to the first. First was earlier pointing to 10. Now the first should now point to the temporary node. What is my temporary node? Temporary node is 50. So 50 will be now my first node. Hence we have considered first is equal to 10. Okay. After this we have to return first. Okay, so only this changes we are doing here. Okay, according to this that is the end of the function. So in this function, you can easily remember this logic. Create a temporary node. Check whether memory is allocated for that particular node. If it is allocated, then continue getting the data part. After you get the data part, then you specify the link part for the temporary node. Then you check whether the list is empty. Okay, when first is equal to node, list is empty. When list is empty, what happens? Your temporary node itself will be the first node. You just directly return that particular temporary node, which will be returned to your first variable. Okay, suppose if list is not empty, if it has some items like 10, 20, and 30, then the temporary node should be added to the first. Okay, so according to our example, 50 should be added before 10. Hence, what you can do, the temp node, that is 50th link part, should now point to 10. Where do I get the 10? By accessing first, because first was earlier pointing to first node, that is equal to 10. Then next is you have to change the first. First should now point to the new node inserted because that becomes your front node. Then you return the first address which will contain the complete list. Okay, starting address of first will be now point to 50. So it will be having the other link also for other nodes. So this is the insertion part for inserting from the front. Okay, so the case one is completed. So the function definition for insert from the front is completed. Similarly, now we have to consider insert from the end. Okay, let us write the function definition for inserting from the end. Same case, you consider the node. Okay, node because it is a structure variable. Node star insert front. Sorry, insert end. So while doing the insert from the end location, so there is no need to specify this as a node because we are not returning anything here. First node is not returned because already we know the address of first node. While doing the end insertion, no need to return that address because we will be knowing the address of first node. Then you can directly consider node first. Okay, we should pass the address of the first node. For doing the insertion at the end, normally, as usual, you have to create the node to be inserted. That can be done using malloc function, which is same as the earlier program. Okay, for doing that, I'll just consider the temporary variable and also a pointer. Let us see why pointer is required. So it is same as the previous function. Define struct list with malloc and specify the size of node. Then get the values for the data part. Enter the USN, name, branch, semester and phone number. Then use scanf for getting the values of all the data indicated. So percentage S for USN, percentage S for name, percentage S for branch, percentage D for semester, percentage S for the phone number. Then you retrieve the values by using the arrow operator for each of the data member, temp of USN, temp of name, then temp of branch, and temp of semester, and temp of phone number. So this is done with the data part. Then specify the link part, same as previous case. So initial case, the link will be assigned to null. Then if it is appended, then we will change the link part. Okay. So when we are doing the insertion at the end, because we have the address of first node, we already know the address of first node. Using the address of first node, I can directly traverse till the end. Okay, so because I need to identify my last node, insertion should be done at the last node. For doing that, we will consider the first address. I'll assign the address of first to ptr. Okay, ptr will just contain the address. Ptr is used for identifying the last node. Okay, so because I cannot use the same variable for identifying the last node and the first node. Okay, PTR is now considered, which will start with the first node. Okay, so since you have to find the last node, you are starting from the first, and now I have to find the last node. For doing that, how do I know the last node? By knowing the link part of that particular node. Okay, so now we should have a repetition or looping constraint included here. So what is the looping constraint? We have to start with the first node. First node is already initialized. Okay, then we have to consider each and every node and specify and check the link part. Okay, let us check the link part for each of the node. So for looping, you can include the while loop. Check the link part of each node. Okay, it is ptr of next. Because it is a pointer, you have to use that as with arrow operator. If pointer of next, that is the link, is not equal to null, if it is not equal to null, I can do that, I can just move to the next node. So how do I move to the next node? By its link part. Okay, this is the link part indicated. So PTR will now get the address of next node. Okay, address of next node will be identified by the link. Okay, so when this while condition will be false, when the value of next, that is link of particular node, is equal to null, then this particular while condition will be false. Okay, so at the end, PTR at the end, I can say at the end, PTR will have last node address. I can consider that PTR will contain the address of the last node. Okay, when while condition is false, PTR will have the address of the last node. Now the last node link should be changed. Okay, suppose consider You have some nodes like 10, 20 and 30. Okay, this is the node, and the temp is 40. Consider temp is 40. This 40 to be inserted after 30. Okay, after 30 it should be inserted means PTR will hold the address of 30. That is my last node. The last node link should be changed. Okay, the PTR link, PTR next, will now be pointing to temp. Okay, it is equal to temp. What happens here? 30 gets linked to be pointed to 40 now. Okay, so this will just change it, and also you consider last node, that is my temp 40. Already we have considered the link of that particular node is equal to null. Okay, so directly you can just end this particular insertion at the end. This is also a very simple function. It may look complicated, but when you understand the logic, you can see we have created a temporary node and assigned the data part, then also assigned the null part. And to do the insertion at the end, I have to identify the last node. Okay, so what is the logic for identifying the last? I have to check my first node, and I visit each of the node until I get the last node. Okay, when you get the last node, you just come out of that particular loop, and then you identify that particular node via the pointer and specify the link of last node to be now pointing to the new node. Okay, new node is inserted at the last level. Okay, after your last node, according to our example, after 30 you'll be inserting 40. So this is an example function for inserting at the end. So similarly, let us understand deletion at the front. Delete front. The concept I have already told you. Using that, you can just specify. Okay, just I'll indicate. Actually, this phi is not required. Okay. So then you create a temporary node, delete from the front. Okay, temporary node, I'll just assign it equal to first. Let us see why it is required. Suppose if the first is equal to null, when list is empty, I cannot do the deletion operation. Hence, you have to check the empty condition here. So if first is equal to null, you can just do the printf operation. We can just display it that list is empty, can't be deleted. Okay, you can just display that, and then you have to come out of the program. You can either specify exit 0 or get ch and just return the first. Okay, the address of first gets returned. Suppose if list is not empty. Okay, when list is not empty, then I have to delete the first item. So just specify what item you are going to delete. The student record deleted is specify percentage yes, because we are just displaying the name. If you want, you can display all other data members also. Okay, this is my first node. Temp, in temp you have specified first. This is the first node. That node should be deleted. Okay, so that deleted node we are printing that that particular record is going to be deleted. Then specify. So after deletion, okay, consider you have values like this. Maybe consider 10, 20 and 30. Okay, 10 is my temporary node. I have to delete 10. So first will be pointing to 10. In the earlier case, first was pointing to 10. After 10 is deleted, first should now point to 20. Okay, I have to change the value of first. So first is now equal to temp of next. Okay, what is temp? Temp is 10 because 10 is to be deleted. That is my first node. So now 20 should be my first node. How do I get the address of 20? By the link of 10. Okay, 10 is temporary node. Hence, temp of next. That is 10 link will be now considered as 20. So 20 becomes the address of that particular node that is equal to first. Okay, so when you write this particular statement, front will be, first will be now pointing to 20. Okay, so then after changing first, then I can release the memory allocated for 10. So how do we release the memory or deallocate the memory? By using free. Okay, so free temp is 10, 10 gets deallocated, then that is the end of else case, then you can directly return address of first. Okay, so this is the logic for deletion from the front. Logic is very simple. We will take the temporary variable. Why temporary variable is required? Because I have to deallocate the memory. I cannot deallocate the memory using the same variable. Then you have to specify in another variable, that is temporary variable. So using temporary variable, you can deallocate the memory. Okay, first you check whether it is empty or not. If it is empty, just specify list is empty. If it is not empty, then you can directly specify the student record to be deleted. Then change the address of first because it should now point to the next node. Then deallocate the memory. Okay, that is deletion from the front. Similarly, now I have to specify delete from the end. So node deletion from the end, that is similar to the previous deletion from the end is specified. So while deleting from the end, you have to identify the last node same as in your insertion. Okay, so we will start from the first node, then we identify the last node. After identifying the last node, I can deallocate the memory. So for identifying the last node, I'll be specifying two variables, that is last and PTR. Okay, initially I will take both the things to be equal to the first node. Then you check whether your last node is equal to null. Okay, so if first node itself is your only node available. Suppose first node itself has null in its link part, then we say that that is the only node available. If that is the only node available, then you can say you can directly delete that particular node because that is the only node. Okay. So when that is the only node, the first link will be equal to null. In that case, directly specify the record deleted is percentage s, specify percentage s, then print the details, print the name. Okay, so then after that you can free your first. First can be freed. So if first is released, then you return the value of null because you don't have any. Because first node itself is deleted. When first node itself is deleted, I can directly specify null because there is no other nodes available. So suppose if you don't have only one node, you have multiple nodes. In such case, I have to find out the last node. Okay. How do we find the last node? By identifying the null in its link part. Okay. So identify. Initially, I am considering PTR is equal to last. Okay. And you keep on continuing until you find the last node. Okay, so after identifying the last node, what happens in this particular case? So PTR will be indicated with the last node. Why we are taking two variables here? One of the variable is required for releasing the memory allocated for the last node. Hence, we are considering two nodes. One is for identifying the next node. Another one is for identifying the address of the last node. Okay. So after that, you can directly specify the record deleted is percentage s last of name. Okay, that is the last node name which is deleted. So after you delete the last node, consider an example like this: 10, 20, 30 and 40. Suppose if 40 is my last node, once you delete 40, the link of 30 should be changed to null. Okay, so PTR will give you the address of the last node. Okay, using that PTR, now I can change the link of this 30. 30 link can be changed, that is PTR of next is equal to null. because 40 gets deleted, 30 becomes my last node. When 30 is last node, its link part to be equal to null. So when link is changed, now I can deallocate the memory for the last node, that is equal to 40. Okay, so once everything is deleted, you directly return the address of first, because that is the address which contain, which can, using that address you can easily fetch all other nodes. Okay, so this is insertion from the end, sorry, deletion from the end. So function is very simple. You check whether there is single node available. If single node is available, directly delete that. That is the first node. So if you have more number of nodes, identify the last node, then delete that last node and also change the link of its previous node to null, deallocate the memory of the last node and return the address of the first node. Okay, so then we will go with display function. So in the display function, it is almost similar to the logic of identifying the last node. Okay, and also you have to specify the count. So initially I'll just consider count to be equal to 0. Then specify node temp to start with first. It is almost similar to insertion at the front, insertion at the end, because we identify the last node. Okay, so temp is initialized to first. Then we will check if first is equal to null. Suppose first is equal to null, there is no node indicated, so list is empty. I cannot do the display operation. Okay, if first is equal to null, it is a list empty condition. You can specify the printf statement, no records to display. Okay, you can specify that. Then you directly return from the particular program. Suppose if list is not empty, then I have to start with first node. Already temp is assigned with first, so I have to do the repetition. How do I repeat until I reach the last node? When I reach the last node, temp will be equal to null. Okay, hence we will have a while condition here, which will start from the first node and it will end when there is a last node indicated. Only when you have a last node, temp will become equal to null, your while loop condition becomes false. Okay, so if suppose temp is having some nodes, you can directly increment the count for identifying the total number of nodes, then specify printf statement, okay, for printing all the records. Printf percentage yes for USN, then specify /t for just space purpose, then percentage yes for name, /t percentage s for after name we had program, percentage yes /t, then percentage d for semester, /t percentage yes for phone number. Afterwards, you can specify /n. Okay, so all these things to be displayed, that is temp of USN, temp of name, temp of program, that is branch, temp of temp, then temp of phone number. Okay, so this is for the display purpose. So first it will display for the first node. Okay, after first node I have to move for the next node. How do you move for the next node? By the link part. Okay, so this is repetition of while loop. While loop gets repeated until you reach the last node. So we will start from the first until we reach the last node. We will be continuing this step and printing the data for each of the nodes. Then you can directly specify the number of nodes, printf total number, because we need to print the total number of records. Okay, so total number of records is, it is there in the count variable, percentage d count. Okay, so that is the end of display function. So after display, next is doing the stack operation. So I already told the function or the concept of stack. We have to just write the function definition. Stack operation, that is node star first. Okay. So here we have to demonstrate push and pop operation using insert front and delete front. Hence, I'll just take the choice here, printf. First one is push operation. We are just demonstrating the stack operation, that is push and pop, using your linked list. That is the concept here. So what are the functions we have to use it here? That is insert front and delete front. So enter the choice. If you want to do the push operation, choice is 1, pop is choice 2. Okay, so we have to read that scanf %d ampersand choice. We are entering the choice, switch case, specify ch. Okay, so sorry, there is no semicolon at the end of switch case. In case 1, you have to specify the push operation. How it is done? It is the insert operation which is done from the front, as I have already explained the concept. That is case 1. Okay, here there is no extra thing indicated here. Only thing is you have to specify uh, front insertion and front deletion. That's all. So case 2 is deletion. How it is deleted? It is delete front operation. So we have to just pass the address of the first node. Then just directly come out of the case. Okay. So this is the end of demonstrating stack. Just return the address of first. Okay. So similarly, like stack operation, we can also perform the queue operation. Okay. So the normally you already know queue insertion will be done from the end, because rear end will be used for insertion, whereas deletion will be done from the front. Okay. Same function, same thing can also be extended for queue. If you are using queue, we have to just call for insertion. We will call insert at the end with first. Suppose if you are doing for deletion using queue, that's same thing. The concept is same for the queue also, but in question it is only asked for stack demonstration. If you want to demonstrate this queue also, so insertion will be from end, whereas deletion will be from the front. Okay, so this is the complete program. Just I'll save this program. I just consider this as list1.c. Okay, let us execute this, compile the program. So there are 2 errors. We shall check what is the error. Sorry, I have not indicated it as branch. I have indicated it as program. And also it is mentioned that the function should return a value. Okay, let us see another error indicated. So there is some unexpected semicolon indicated. Okay, I have added an extra colon. It's okay. Okay. So now I can directly execute. There are no 1 second. Still there is an error. Undefined symbol. Okay, display. I think I have made spelling mistake. Okay, DIS. Then you can directly execute. Okay, this is a single linked list. First operation, let us go with the first one, for choice 1. Choice 1 is for display, as choice 1 is for creating the creating the complete list for the number of students. I'll just initially for number of students I'll consider 1. Okay, memory is allocated. Now I have to enter the USN. So USN is considered as character. I'll just give it as CS01. Name, I just consider it as John. And department, I'll consider as PSC. Semester is 3. And phone number, I'll just give the random phone number. Okay, so the list is now created. Directly I'll go for the display, that is 6. Okay, you can see it is displayed, that is CS01, John, CSE 3 and phone number. Total number of records is also displayed. It is equal to 1. Okay, then we will go with the choice 2. Again, I am trying to insert another record, choice 2. So memory is allocated. I'll go with CS02 for USN. Name something like Smith. Branch I'll consider EC, semester is 3 and phone number is to be specified. So after it is specified, uh, so now there are two records. I'll give 6 to be displayed. You can see two records are displayed. Okay. So in first choice is correctly working. Second choice insertion from the front is also working. So when insertion is done from the front, okay, you can see the last inserted node is on top, that is CS02, because that is my first node now. Okay. Similarly, let us go with choice 3. So choice 3, I'll just specify some USN like CEC02. Name, I'll just randomly indicate John only. Okay. John S. Something like that. EC, semester is 4. Phone number, some phone number. Okay, so I have considered choice 3. You check with the 6 display. Okay, so it is insert at the end. Since insertion at the end, you can you can see directly that is inserted at the end. So last inserted EC02 is at the last position. Okay, so now choice 1 is done, 2 and 3 is also done. I will check for the choice 4, that is front deletion. Front deletion is Smith should be deleted now. I'll give choice 4. You can see the student record deleted is Smith. That is front is deleted. Again, you also check with the display. So that particular record is also displayed. Okay, front deletion is working. Now I'll check with the deletion at the end. So deletion at the end, last, that is EC02 should be deleted. I'll give choice 5. You can see the record deleted is John S. So John S is the last record to be deleted, that is deleted. Check with the display, there is only one record available. Okay. After that, you can also go with the demonstration. Again, I'll give choice 4. There is only one record, that is John. So John is deleted. Then you give display. So after you give display, since all the records have been deleted, there is no records to display. Okay. So now we will go with demonstration of the stack. So when demonstration of the stack, it is two operation, push and pop operation. I'll give choice 1. So memory is allocated for the first node. You can start inserting same as previous case. Okay, semester is 5, some random phone number. So this is pushed onto stack. Okay, so and also it is considered as a list. Specify 6, it is displayed. Okay, it is successfully inserted and the total number of records is equal to 1. Similarly, again I give choice 7 to do the pop operation. So there is only one record indicated that should be popped out. Okay, I'll give choice 2. You can see that particular record is deleted. After it is deleted, if you give choice 6, there are no records actually, because push you have inserted one record, and using pop you have deleted that record. As of now, there are no records in the particular nodes. Okay, the particular linked list. So these are all the operations, that is creation, insertion from the front and end, deletion from the front and also from the end, display, and also demonstration of the stack. So and finally you can give 8 for the exit case. It is coming out of the particular program. Similarly, you can also verify for the queue operation, as I have already indicated here, that is for the insert is for inserting at the end, whereas delete from the front. Okay, so this is about the 7th lab program. You can start working on that and also complete the tracing for this particular program. And okay, so thank